So in this video, we discuss about the linear vector space. So what is linear vector space and what are the properties of the linear vector space? So that's it is discussed in this video. So first, what is linear vector space? So if we consider the set capital L, which is equal to u, v, w, etc. So in which elements can be multiplied by complex number alpha are added to one another to give the members of the same set is said to be from the linear vector space L. So the set it is considered the number of vector elements here u, v, w, etc. So these are called the vector elements. Suppose we multiplied by the complex number alpha to the vector elements u, v, w, etc. are added to one another, that is u plus v plus w, etc. So it is gives the members of the same set, that is if we add the vector elements or the complex number, it is multiplied with the vector elements, so which is same is in the set. So we can say, so this is from the so these are from the linear vector space L. So this is the definition for the linear vector space, which means if we multiple by the complex number to the vector elements or the vector elements is added, so the vector elements which is also form the linear vector space. So the linear vector space which is represented by the letter capital L. So the elements of the vector space are vectors. So the elements in the vector space, that is u, v, w, etc., which is called the vectors. So u and v are in linear vector space L. Then the complex number, it is multiplied with the elements, that is alpha into u. Suppose we add the two vector elements in the linear vector space u plus v. So alpha u and u plus v, which is also in the linear vector space L. So the operation of multiplication and additions must satisfy the conditions. If you perform the two conditions, that is the vector elements is multiplied with the complex number or the vector elements are added. So these multiplication and additions must satisfy the conditions. So first one is, it is obey the commutative law of addition, that is u plus v, which is equal to v plus u. So this is the first. Then second one is it is obey the associative law of addition, that is u plus v plus w, which is equal to u plus v plus w. Then third, it is obey the distributive law of multiplication, that is alpha plus beta into u, which is equal to alpha u plus beta u, or alpha into u plus v, which is equal to alpha u plus alpha v. So the multiplication and addition of the linear vector space, which is obey the distributive law of multiplication. Then fifth one is the linear vector space multiplication and additions, which is also obey the associative law of multiplication, that is alpha beta into u, which is equal to alpha into beta u. Then sixth one is the I into u, which is equal to u, that is I is the identity or unit operator. So the linear vector space L will contain a 0, that is null vector 0, such that u plus 0, which is equal to u for all the values of u. So thus the linear vector space L forms an abelian group under the addition operation, and its elements can be multiplied by a complex numbers. So the linear vector space, which is also referred as a linear space or vector space. So final, we can say linear vector space is nothing but the it is contain the number of vector elements. So the vector elements, it may be multiplied by the complex number, or the vector elements is added itself. So which is also, it belongs to the linear vector space. So the multiplication and additions, which is must satisfy some certain condition, that is commutative law of addition, associative law of addition, distributive law of multiplication, associative law of multiplication. So the linear vector space, it is forms an abelian group. The linear vector space, which is also referred as a linear space or vector space. So the concept of the linear vector space is used in quantum mechanics. So the application of linear vector space is in the quantum mechanics, which is describe the system of the vector elements. So for this case, we can apply the concept of the linear vector space. So it is very useful in the quantum mechanics. So thank you.